Hey, Katie.
Hi, Ben.
So, what are we talking about today?
We are talking about some pretty nifty ways that you can get causal effects out of observational data. Specifically, difference in differences, which is great, and synthetic controls, which are even cooler than they sound.
Okay, you are listening to Linear Digressions. Did you say differences?
Difference in differences.
Difference in differences.
Yeah, often people call it diff and diff because it's
Diff and diff, okay.
a little bit fewer syllables, I guess.
What does that... Do you know where it got its name or like what it actually means? Because like coming into it cold, difference in differences doesn't say very much to me.
Sure. Well, I think we should just explain the algorithm and then it probably makes a little bit more sense. So in order to queue up the algorithm, let's talk about causal inference for a sec. So in causal inference, we're trying to study treatments and whether they cause differences in outcomes across like people or regions or cases or units of analysis, whatever those are. And the gold standard way that usually we'd like to study causal inference is by running a randomized controlled trial. So it's really hard to know in general when you see different outcomes. Well, was that outcome because I gave some of these, let's call it people for the sake of the conversation here. I gave some of these people the treatment and some of these people the control or some other treatment or whatever. Or is it because those people were actually just fundamentally different to begin with? And maybe those differences were had some impact on whether they got the treatment at all. I gave all of these people this particular medicine for some illness they had, and then they all seemed to get better, but also those people were younger and healthier, and maybe they would have gotten better anyway. Like, it can be really tricky to understand like causal effects in that situation.
And we've talked about causal effects quite a bit on this podcast, but I guess in different contexts. Like we've talked about A/B tests, for example, where in a lot of cases you can get a pretty clear separation and a pretty close to true randomization of your users. But that obviously doesn't work if, say, you pass some legislation in a city in the US or something like that. You can't really split the city in half and say, okay, this half of the city randomized gets this legislation and this half doesn't.
Yeah, that would be pretty tricky. And yet, political scientists or marketers, we'll talk about a couple cases in political science and marketing where you still want to be able to study causal impacts, but all you have is observational data and it was not randomized. So what can you do in that case? That's what difference in differences and synthetic controls try to do. So with that as a preamble, let's talk about difference in differences. And let me use a particular paper as kind of a grounding point here. We'll have a link on lineardigressions.com, but this is a paper about trying to understand the causal impact of search engine marketing for eBay. So are you familiar with search engine marketing?
Search engine marketing is you put an ad in front of somebody and I guess the goal is you put an ad in front of them and then they are more likely to buy your product.
Well, kind of. It's a particular kind of ad. So it's the ad that pops up when you do a Google search. Let's say you're doing a Google search for eBay. Yeah. So if I type if I type eBay into the Google search bar, the first thing that I might get might actually be an ad, a paid ad for eBay. And then the first organic result that I get might be the eBay homepage, which might point me towards the exact same place, but one of them is paid and one of them is organic.
You know, when that happens, if I don't like the company, I'll click on the sponsored link. And if I do like the company, I'll click on the non-sponsored link.
Yeah, me too.
Because, I want to I don't know, cost them half a cent a nickel or whatever their CPC is.
Yeah. So, but if you're the company on the other side, you're like, I just paid for a conversion that maybe I could have gotten for free.
Oh, interesting.
And that's super annoying. And so,
so that's what you're talking about causal inference is like, if you see an ad for eBay, but then the first organic result is for eBay, if you run the ad, someone would click on eBay. But what if you didn't run the ad? Would they still click on eBay?
Yeah, and so the difference between like those two outcomes, you can say if they clicked on it in the world in which they got the ad, but they didn't click on it, they never went to the eBay homepage in the world in which they didn't get the ad, then you could say that that ad like caused the conversion. Whereas if they end up on eBay anyway, they just follow the organic result, then you can say like you can serve them ads all day, but it doesn't actually generate any net new traffic to ebay.com. It just like makes it more expensive.
Right. And of course, searching for eBay at Google or on Google is kind of a contrived example. You could also imagine the person searched for buy stuff online. And then, maybe eBay is the first or second organic result, but then eBay also purchases some ad space at the top.
Yeah, I suppose that's true too. Yeah. So this is the conceit. But if you're eBay, you're probably really curious how much traffic you're driving to your site through search engine marketing or paid search ads. But your marketing department is probably not super excited about the idea of just turning off all of their ads and seeing if anything happens. It can take a long time to measure those effects. And moreover, like let's say you get kind of unlucky and at the same time that you turn off all of your ads, there's also, I don't know, other stuff that's happening in the world. Let's say that it's a bad week for the economy. And so traffic is down all across the internet shopping sites. Or maybe traffic is up a little bit, but it's the same week that it was up last year relative to the week before and the week after. And so maybe that's just a seasonal thing. And, it's really hard to say whether anything was caused by anything else.
Right. So week to week, things are not necessarily the same.
Yeah. So in general, just turning off all of your ads and seeing what happens it can be a little bit hard to say any changes that you see, like what caused them. But if you had a world that you could live in where you simultaneously turn off the ads and you keep the ads running, you live in two different parallel universes at the same time, and you see what happens in those two parallel universes. And they're subject to the same economic shocks and the same seasonality effects and all of those kinds of things. And then you can subtract those from each other. And that starts to look a lot more like a causal effect because, well, if they're truly parallel worlds, then the only difference between those two is whether the ads are running or not. And that's pretty close to what our definition of causal inference is.
Right. Okay. So ideally, you could just kind of split the universe in two, and in one universe, you run ads, and in one universe, you don't run ads. And then you compare the universes. Obviously, we can't do that. So what's a way that we can accomplish a similar thing?
All right, so now we're starting to arrive at difference and differences. So here's the rough idea. Yes. So you turn off the ads in some places, but not in all of them. And you look and see if the change is through time is different for the people who keep the ads and the people where you turn off the ads. And very often you're doing this not just on an individual level, but on, in the case of this case, they turned them on and off at the DMA level. So a DMA is like a marketing area. It's like a geographical area. So think of it as like a city. Maybe that's a good unit of analysis. I can turn or let's imagine that they're not paid search ads, but they're like TV advertising. So you can turn them on and off at the regional market level.
Right. Okay. But I mean, you kind of have a problem, right? Because if we're thinking of it as cities, different cities are different from each other. Right.
So what you do is before you start monkeying with any of the ads, you try to pair up cities that are as close as possible. And the way that you understand whether they're as close as possible is, number one, you try to think of all of the different variables or attributes of a city that could be relevant. So in this case, it might be stuff like the economic base, the socioeconomic profile of the city, racial profile of the city. There's probably more things like this that we could think of if we sat here and brainstormed for a while. But, try to think of all the things that might have an impact on how cities shop. And you try to find cities that look as similar to each other as possible. So we were talking a little bit right before we started recording, and I was trying to brainstorm about cities that might look sort of similar. So the ones I came up with were like, I don't know, Cleveland and St. Louis. These are both cities that are in the Midwest. They're kind of post-industrial. I don't know anything about their racial or socioeconomic profiles, but I don't have any information that tells me they're dramatically different. So I don't know, all other things being equal, maybe these are two cities that are pretty comparable to each other. And I can make an educated guess about what pairings they are, but I can be pretty data-driven and quantitative in testing this by basically watching Cleveland and St. Louis, watching them move together, ideally, in the period before I start changing any advertising treatment between the two of them. So I can validate that they're generally doing the same thing at the same time, which gives me some confidence that they're pretty good doppelgangers of each other.
Okay, so would the next step then be you turn off the ads for one of the cities and you leave the ads on for the other, and you just kind of assume that they're similar enough that you can treat them as almost like an A/B test?
Yeah, that's the rough idea. So you had some notion of the difference between those two, whatever difference there was between those two cities before any changes in treatment. And then there's the difference between the cities that you see after the treatment. So there's the difference between the two cities, and there's the difference before and after. And the difference in those differences is, if you've done a good job matching them, is something that you can attribute to the causal impact of your treatment.
That's the name, difference in differences.
Exactly.
Got it. Thank you. That connected. Okay, so I see one problem with this.
Okay.
Which is that I am a wonderful, unique snowflake, and so is my state, California. I can't think of any, if we're going on a state level instead of a city level, I can't think of any state that's the same or similar enough as California to do this.
Yeah, and you folks over in California have all kinds of weird, interesting things that you do legislatively. I say this as a former Californian. Yeah, and
strange people.
Yeah, and you could even argue that. I mean, I know you live in Silicon Valley. Silicon Valley as a city is it's there. It would be really hard to come up with another city that's a good pair. I mean, it's not, Silicon Valley isn't even really a city, but you get the idea. Sometimes it's really, really hard to do the pairing, or you might just be skeptical about the pairing that you're able to get. Like, I don't know, maybe St. Louis and Cleveland isn't actually a very good matchup. And so in this case, now we're moving on to synthetic controls, which I think is such a cool idea. So synthetic controls. So we have this notion, the control part comes from the idea of, usually when we talk about, or very often when we talk about experiments, there's kind of like treatment and control arms. And so treatment is the one that you're messing with somehow, and control is, the idea is that's the one where you're kind of maintaining the status quo. There's a really good paper that we'll have a link to on lineardigressions.com. It comes out of political science. And what they were trying to do was actually in California, they're trying to study the causal impact of a piece of legislation called Proposition 99, which was an anti-tobacco legislation piece that passed a couple decades ago, maybe. So at the time, tobacco use all across the United States was falling, and it was falling in California too. So if you look at overall tobacco usage across California, it starts to decline in like the 70s or 80s or so. Proposition 99 passes in, if I recall correctly, like the 80s or the 90s, and it's kind of midway through this like long decline in tobacco usage. So tobacco usage goes down after Prop 99 was passed, but it was already on a trend that was going down. And that trend is reflected across the entire United States. So you can look at all the other states that didn't have tobacco usage, didn't have tobacco legislation being passed, and they're also declining as well. So it's like, okay, did it do anything, or was the decrease something that was just going to happen anyway? That's the problem. That's the question we're trying to answer here.
I see. And you also can't compare California, let's say, to itself, like before and after, because of that decline. You don't know how much it would have declined if the legislation had not passed.
Right. But so let's say that the treatment world is the one in which Proposition 99 passed because we kind of changed something. What's the control world? Well, like we said, there's no perfect control for California. It's a pretty unique state in many ways. But there were 38 other states where we can look across roughly the same time period that didn't pass other types of tobacco legislation. There were some states that did pass tobacco legislation and these kinds of things that were going on. So restricted down to 38 other states. And those 38 other states, what a synthetic control does is it finds a series of weights that it distributes across those 38 other states. So you multiply each other state by its appropriate weight, and then you add them all up. And those weights are kind of taking into account all of the stuff that makes California look like California. So you take like a little bit of New York and a little bit of Florida and a little bit of Nevada and a little bit of Ohio, and you add it all up and you make a fake California that didn't get tobacco legislation passed. That is your synthetic control. And you see what happened in fake California. And the difference between those two is you can make the argument that the difference between real California and fake California that didn't have this legislation passed, that is the causal difference or the causal impact of that legislation.
That is fascinating. And so you build the synthetic control by looking at historical data of all of these states, and then you kind of do your best to combine states that are similar in some ways in such a way that the historical performance of your combined Franken California is very similar to the historical performance of California itself. And then you make the assumption that if all of your historical data and combined data and everything is the same between California and Franken California, then moving forward, Franken California does not have the legislation passed, but California does, and you assume that they would have fallen at the same rate if California had not passed the legislation.
Yeah, so it's kind of like difference in differences on steroids, where instead of having some doppelganger California, we're creating this fake one, and we're creating it out of this combination of all this other stuff. And then, there's some mathematical fancy footwork. You aren't just kind of like making up these weights, but instead there's some way that you can kind of solve for them based on what you're able to observe in these states before you start making any changes across the two different cases. But anyway, putting all of this together, you come up with this synthetic California. And I mean, not to bury the lead here, but in this particular case, they found that the tobacco legislation did have an impact on the amount of, like, the overall decrease that they saw was larger than if the tobacco legislation hadn't been passed. So it looks like it did something. But of course, we here on Linear Digressions are just as interested in the methodology as the outcome. So pretty nifty, huh?
Very, very cool. I do wonder what it would be like to live in Franken, California.
Well, it'd probably be the same as regular California, except people would smoke more.
I mean, would you have to pump your own gas? Like, there are all kinds of other differences.
I mean, we could make a fake California that has different gas pumping policies. I guess that would be kind of hard. There's not that many states where... Oregon, New Jersey...
It is so strange to drive through Oregon coming from California, because then you can't pump your own gas.
Yeah, I think that would be a challenging synthetic control. And you also, I mean, synthetic controls are really designed to measure the effect of kind of like shocks to the system. So something changes and you're like, what impact did this have long term? There's like some other paper that's pretty famous that is trying to understand, there was this influx of Cuban refugees or immigrants or something. I didn't read this one in detail, but a bunch of folks came from Cuba over to Miami at some point, and they were trying to understand what the impact on the Miami labor market was. They made like a fake Miami, if I recall correctly, these kinds of things. So you're measuring the causal impact of shocks to the system, if you like. That's where it shines the most. And of course, there's all kinds of assumptions that you have here, like anything that shocked real California also shocked fake California in roughly the same way, so that's not, causing any of the differences in the outcomes that you see. So there's still assumptions here, and synthetic controls, obviously there's probably a little more mathiness involved, but still pretty nifty, I think.
Very cool. I'm happy I live in California.
Real California?
Real California, yeah. having grown up here, I can't really tolerate temperatures elsewhere. So
I was gonna say, well, as I am recording it right now, I'm listening to the freezing rain hitting my window. So yeah, rub it in, why don't you?
Oh, I'm sorry.
That's okay.
Linear Digressions is a Creative Commons endeavor, which means you can share or use it any way you like. Just tell them we said hi. To find out more about this or any other episode of Linear Digressions, go to lineardigressions.com. And if you like this podcast, go ahead and leave us a review on iTunes so other people get to listen to this content too. You can always get in touch with either of us. Our emails are ben@lineardigressions.com and katie@lineardigressions.com in case you have comments or suggestions for future shows. You can tweet us at lindigressions. Thank you for joining us, and we'll see you next time.